For our course project, we decided to do the design and assembly of a ceiling fan. I'm Hunter Rising.
I'm Taylor Landry.
And I'm Amber Riggs.
So now I'm going to give a brief description of the project background. We decided to design and assemble a normal household ceiling fan. Our model includes 10 different parts. It's a fan base, a simple motor, a blade attachment arm, small bolts, small washers, large bolts, large washers, a lighting fixture, and a glass lighting cover. We designed and assembled a ceiling fan that will be interesting because there's a multitude of parts that are in the design of the fan. When we designed the fan, we designed for like a manufacturing standpoint where your consumer doesn't want many parts to assemble, so we're trying to reduce the amount of parts overall. When manufacturing, we put the motor as one separate part because it would be very difficult for a consumer with not much knowledge to assemble a motor. This is a picture of the completed assembly. We have a bunch of individual pieces and parts of the assembly that'll be showed after this.
The first step in our design assembly was to create a subassembly of the motor and base. The base is an anchor for the rest of the fan, holding the motor in place for the blades to be attached to. This slide shows the motor. Every fan needs a motor that allows rotational motion. The motor moves the stationary arms in a counterclockwise direction, allowing cool air to descend from the ceiling and circulate in the room. Here we have the arm and the blade. The blade creates air movement, and the arm attaches and secures the blade to the motor. This ceiling fan design requires 5 fan blades. For ease of assembly, a subassembly was created, including a blade, an arm, 3 large diameter bolts and washers, and 2 small diameter bolts. Then the blade subassembly was assembled using a pattern onto the motor in Creo. The small bolt and washers are used to attach the arms to the fan motor. The small bolts were assembled in the arm and blade subassembly stage. The small washers were assembled using a pattern onto the fan motor. The larger set of bolts and washers are used to secure the blade to the arm. The large bolts and washers were assembled in the arm and blade subassembly. The light fixture is a metal rod extending from the motor containing wires and bulb sockets. The glass cover is fixed to the light fixture, and its function is to protect the light source. And this slide shows the exploded view of the full assembly of the ceiling fan.
Here we have the top view of the assembled ceiling fan, and there's another view showing all of the motor, the base part, the light fixture, the lighting protector, the blade, arm pieces, bolts, and everything put together. This is our arm piece. We used the arm piece to do our milling manufacturing plan, and we ended up milling out the entire arm piece for all of them. We also took the arm piece for our DFA, Design for Assembly, and we decided to redesign it, change it up a little bit so that we could reduce the amount of bolts and washers that we will be using in our assembly to minimize costs and reduce the overall assembly process. When we redesigned our arm piece, our main focus was to remove a hole that we had attaching the arm piece to the blade, and so now that it only requires 2 sets of bolts and washers instead of 3, and since of 5 blades on our fan, that's 5 extra bolts we don't have to worry about assembling. For our summary and conclusion, by reducing the amount of parts needed to assemble the fan, we made the process a lot easier. We made the assembling of the fan a lot easier for us and for any consumers that might need to assemble it at home. In conclusion, we incorporated DFA to improve the assembling process for the fan, and by removing unnecessary parts, we improved the assembly process and made the process more user-friendly with less processes and parts.